So to prove this, the proof works really in exactly the same way as for when we've got cot here and a minor, and without the minus 1 to the n. So basically we again consider a square contour, and the poles of cosec, that's 1 over sine, are in the same place as the poles for cot on the integers. The only difference is when you work out the residue. So let's just check what we get when we work out the residue of f of z. I'll write it as over sine pi z at z equals n. Okay, so this is where n is not equal to a pole of fj. So it's a simple pole. So p over q, so q dashed, we end up with f of n divided by cos of pi n. And then differentiation the sign gives us pi times cos pi z. So we end up with, now cos of pi n is famously just equal to minus 1 to the n, a useful formula, so remember if you don't already. So before we had, without this, with cosec we get this extra minus 1 to the n, which is why we get it here. Otherwise the formula is the same.